Hello, SGD, Sacred Geometry Decoded. In this video I want to have a look, if you've seen Scott Onstott's Secrets in Plain Sight series, and they've shown how the pyramid plan, does it correspond to the Nile Delta. Now, for instance, at Giza, where we have the Great Pyramid, we also have Alexandria and Port Said, where the Suez Canal is. But what's being suggested here is that the pyramid plan again corresponds to the Nile Delta. And so we have the Great Pyramid, and okay, so there we see the angles. So for instance, 38.16 and 51.84, that would naturally be a 90-degree angle. Now, so the half base being 220 Egyptian royal cubits, or 440 Egyptian royal cubits, the whole of the width, and 280 Egyptian royal cubits high. So what they've done in this projection is simply multiplied the size of the Great Pyramid times 1,000 to get 280,000 cubits, as in the height, or 440,000 cubits, as in the width, times 1,000. And again, to get that 51 degrees, 51 minutes, which is 51.84, give or take an ever so slight fraction of a degree. Now on this projection they have it 356,000 cubits. Well, if you, again, using Pythagorean theorem, so that if it's 280 Egyptian royal cubits high, and if the half base is 220, that would make the slope angle 356.089876. Now the slope angle is from the very top down the middle of the face, not the angle at the corner, but so the 2D cross section of it multiplied by 1,000. So using those figures, and so what is an Egyptian royal cubit? Well, we have various cubit rods. This is a cubit rod of Maya, for instance, 14th century BC, and I'll put the links in the description to a series I did on the Egyptian royal cubit, testing it against the pyramid measures, which is slightly different from this later Egyptian royal cubit, but the cubit is based from your elbow to the tip of your finger, and the cubit is then divided into 7 palms, as in the width of your palm. Then each palm is divided into 4 fingers. Man is the measure of all things. Now, what's interesting is if you get the modern meter, create a circle of 1 meter diameter, and you draw the seed of life, which divides the circle into the hexagon. Therefore, each portion of arc is 1 Egyptian royal cubit, pi over 6 meters. And of course, because the diameter of this, circumference of this circle has to be pi meters, therefore divided by 6. Links will be in the description to some more info on that. Now, the meter of the Egyptian royal cubit as a unit of length, but also as a unit of time. Now, if you get a 1 meter long pendulum and swing it no more than 30 degrees, because if you swing it more than that, it will affect the timing. But 30 degrees of 1 meter pendulum is pi over 6 meters, which is 1 second, depending on your location on the earth. But that will links to that in the description, because it all connects. Even the margins of error in the measurement beautifully connect to time and measurement. And it's also worth noting that Giza plateau is let's just round it off ever so slightly. It is 30 degrees north of the equator, just like a pendulum needs to be swung no more than 30 degrees, which creates an Egyptian royal cubit, which creates a second. 86,400 seconds per day, multiply that. Anyway, now the connections between the foot, the Egyptian royal cubit, and the meter, add them together, you get the height of a 6-foot man within less than 1/2 of a millimeter. Again, man is a measure of all things. Now, so that's 1/10 of a millimeter of inaccuracy from each of those. And well, the whole thing about measures, exactly how they are, it always leads to some rounding off, and historically what they've been to what they are. But we'll put that to the side now. Now, the pyramid itself is, no one side of the pyramid is exactly 756 feet, and no one side of a pyramid is exactly the same. Each side is a slight variation. If you include these variations, what you actually get is perfect proportions of phi and pi, but perfect phi and pi in meters as well, which links back. But slight variations, which these will also affect the angles. But in this video I'll be using the idealized measures, 440 Egyptian royal cubits base, or 220 half base, and 280 Egyptian royal cubits high, creating these angles. So that's what I'll be working off now, and then I'll be multiplying those by 1,000. So at Alexandria, where this one side should point to, we have the Lighthouse of Pharos. Pharos was formerly there, one of the 7 wonders of the ancient world. Another one of them being the Great Pyramid itself. The Great Pyramid is the only of the 7 wonders of the ancient world which is still relatively intact. There are foundations of we know they exist. There's still bits and pieces of them, except for the Colossus of Rhodes. But again, the descriptions of that. Now, on the other side at Port Said, also the Library of Alexandria, of course, is storehouse, centre of learning and knowledge and astronomy, just like Heliopolis was. Suez Canal, Port Said, that's one of the marvels of modern engineering, but so that's an important point. So now they were all north facing down, so let's look at the map facing upwards, and so we have Alexandria and the Lighthouse of Pharos, Port Said and the Suez Canal, and the Great Pyramid. So that's the Great Pyramid there. Because of the angle of a shot, it looks like it's smaller, but it's actually the largest of the pyramids. So that's the Great Pyramid. Now, if we test that, also at Port Said, original concept Statue of Liberty was of an Egyptian Arabian woman freed from slavery, and that was going to be a lighthouse as well. So another lighthouse. But if we project from the Great Pyramid and we project it out through, and use that pyramid angle, well, that line at 38.16 degrees runs right through the guts of Port Said. And so, again, using the idealized measures, 38.16 degrees, multiply the slope of the 2D cross-section times 1,000, we get 186.448 kilometers. 186.45, and now 186.45. So that's where it would be, just offshore. Now, this is a delta, so the deltas are always shifting. So at the moment, but even acceptable margins of error in measurement, because as I pointed out earlier, each side of a pyramid is slightly small variations on each side, which will affect the angle. But just working off the idealized measures, that's where it would be. So very, very close. On the other side, to the west, if we project that line out where we get, that's where it should end up. Just again off the coast there of Alexandria. It doesn't pass through the old city or the Lighthouse of Pharos. Very close as well. Now 321.84 degrees. That's 360 minus 38.16, and if we multiply again, 186 point, this is rounded off to 0.45. So that's where it would be based on those systems, and once again, there's slight variations in the measures. This could account for that. So that's what we're looking at, where it is very, very close now, and it's including the variations, could be even closer. So there is something to it, whether it was intentional or not. Okay, that's without a smoking gun document, that's hard to say. But I also thought about, well, what about if we extend it out a little bit and, for instance, we carry it on, and what we have is pointing to here, and that's the Nile, that's the Sinai Desert. Now, so that's the point where it would lead to. There we have, that's the capital of the Sinai Governorate, and Governorate, and that's where the point is. Now, this area is historically important for, there are temples here, but it's also a center of mining. And so what was mined here was still, actually what's still being mined now, it's almost being continuous, was copper. And the copper from the Sinai is especially rich in arsenic. Gold and turquoise was also mined here. And, well, these are actual ancient Egyptian chisels, not exactly sure where these locations were. But copper alloys such as arsenical copper or bismuth and the other impurities actually make the chisel stronger. So on a side note, if you've heard about Mohs hardness scale, you can't cut limestone with copper, absolutely incorrect. Firstly, arsenical copper or these copper alloys are actually harder than limestone, but still the Mohs hardness scale has essentially nothing to do with the ability for metals to work stone. That's a different, completely different thing. Mohs hardness scale has got to do with abrasives, and reconstructions have shown that copper can work. Firstly, limestone, even soft, pure copper. The reconstructions you might have seen all use pure copper. They were not using that. The actual ancient Egyptian chisels, as with the Mesopotamian copper and elsewhere, is impure copper, the impurity usually being arsenic or bismuth or tin, which makes the copper harder. So that's a furphy, that whole thing. But now, so where is that? That's pretty much smack bang in the middle of the Sinai. This was one of the earliest regions conquered by the Egyptian Empire. The expansion, Egypt was traditionally limited to the Nile, but there was an effort to expand, and for instance, they later moved up onto into the Eastern Mediterranean there. But if we zoom in, so there you can see, if we were to follow that red line down to Nicole, so there we see the point, and there we see the capital city of that Sinai Governorate. But if we zoom in on that location, it's hard to be sure, but there's a lot of, so that's where the spot would be, or within very, very, very close to that, based on the best using Google Earth. But what we also have is what seems to be quite a bit of evidence of mining, because it is literally still a centre for copper mining, especially. It's more seasonal now, but you can see like these tracks through there, and what appears to be lots of earthworking equipment in operation where they're moving. And if you were to follow that, even just from the colorations, but you can see a lot of earthwork being moved, and again, it's still a site for mining. And again, you see a lot of this type of stuff on there. So still, historically, it's been an important mine for copper. Now they'll get the slag heaps that they've found, ancient slag heaps, the ancient mine. They're getting a lot of copper out here. I can't think, maybe was it 4,000 tons per year. So again, when you might hear, oh, where did the Egyptians get all this copper? Well, they're mining a buttload of it in the eastern desert. But in the Sinai as well. And so again, you just follow this road, and there's a high power electric cables as well. And you can see evidence of mining, and it's still going on in operation. And then we come down to Nekal or Nexul, depending on I'm not exactly sure of the pronunciation there. So overall, that projecting the Great Pyramid out from it does follow the delta, for one thing. If you were to draw an arc, follow it like to draw a circle. So if a circle center was on the Giza Pyramid, it also follows the delta as well. And it again does, it could be, like at least it's modern Port Said and the Suez Canal. That would be a nice link. And historically speaking, and again using within margins of error, it's coming very, very close to Pharos and old Alexandria. So it's overall, it's much, much, much more true than it's untrue as to whether it was intentional design back in ancient times when they constructed the pyramid. Well, that's one of these things you can't be sure of, but at least on a mapping sense, within margins of error, ideal measures versus the actual measures of a pyramid would bring it even closer. So also worth noting is, and I'll lead to that in the next episodes, because by some methods the Great Pyramid is the geographical centre of a land mass of the Earth. I'll lead to that more because the omphalos and the world, the centre of the world where it politically and financially, it's moved. Anyway, with that, more to come.